Hello, I am Flash Isaac, and today I shall be taking you through plane geometry. Now, geometry is a branch of mathematics that studies the size, the shape, the position angle, and the dimension of things. That is geometry. In mathematics, we have different types and branches of geometry. But today, we are focusing on plane geometry. In mathematics, we have points, line, plane, and solid. Points, they are positions. They don't have dimension. Once I draw a point like this, it is a position. It doesn't have any dimension. So that is a point. If I say angles at a point, I simply mean different angles coming together at a particular point. So all these angles at a point, they are 360 degrees. Then from position, you move to line. When you draw something like this, you are drawing a line. And lines are one dimensional. In dimensions, you can talk about x axis or y axis, just a single axis, either like this or like this. These are lines. They have one dimension. Then from lines, we move to planes. When lines join, you form planes. For example, this is a line, this is a line, this is another line. Once they join, something like this, lines coming together, they form planes. Planes are two-dimensional. They are also referred to as flat shapes. So planes are 2D. You can have x axis, y axis coming like this. Then from planes, you move to solids. Solid shapes, they are three-dimensional. You can see this block. It is a solid shape. Now, plane geometry, they don't get up to solid shape. We are focused on 2D, or we are focused on plane. Now, what is plane geometry? Plane geometry is simply the geometry that studies flat shapes. Yes. And what are examples of flat shapes? They are the triangle, polygon, square, circle, rectangle. So any geometry that is talking about triangle, polygon, square, circle, or rectangle, or polygon, any geometry where we study triangles, polygon, square, circle, and rectangle, they are referred to as plane geometry. Now, this class serves as introduction to plane geometry or introduction to geometry. And the area we shall cover in this class are triangles. Triangles, the angles in the triangle, the types of triangle. Then we shall cover angles, different types of angles. What are the types of angles that we have? Then we will cover terms used in plane geometry. So with all this, we call it a day. But trust me, other videos will come to cover polygons, square, circle, and rectangle in details. Now let us begin. Triangles. Triangles. Triangle is a shape studied under plane geometry, or triangles are shapes that are studied under plane geometry. What is a triangle? Triangle is simply any shape with three sides. Yes, it can come in different forms, but so long it has three sides, it is simply a triangle. For example, if I give you something like this, something like this, something like this, something like this, something like this. So long it has three sides, it is referred to as a triangle. We can choose to number the sides. You can call this side A, side B, side C. A, B, C. A, B, C. A, B, C. A, B, C. So anyhow you choose to number the sides or to name the sides, you are correct. And now these sides can be in different values. And the sides, they refer to the length of the triangle. So remember, the units of length are meter, centimeter, millimeter, and so on. If we are taking this to be in meter, so you can call this 2 meters. Then you can call this 2 meters, 3 meters. So the side depends on the type of triangle. For now, let's leave it in terms of values. Since triangles have 3 sides, they also have 3 angles. And what are angles? Or how are angles formed? When you have a line and another line crosses, angles are formed. They are inclined. You have something like this, another one comes here, you've inclined it. That is an angle. So here we have an angle here, we have an angle here, we have an angle here. We have an angle here, we have an angle here, we have an angle here, an angle here. In this case, you have an angle like this, an angle here. I will explain later. In this case, an angle here, 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 an angle here. Which means, so far, we know that triangles, they have 3 sides and they have 3 angles. Now you can choose to name the angles. The angles are in degrees, but since we don't know the exact values yet, or since we are not assigning values yet, you can say since we have side B here, let this angle be the angle for B, capital B. Since we chose here to be side C, let this angle be the angle for C, capital C. Since here is A, let this angle be angle for A. We've named the angles. If I ask you the question, what is the value of this angle? What would you tell me? No, because you can actually not tell. I have not given you the information you need to tell me the angle. If I also ask you, what is the angle here? You cannot tell because I have not given you the information you need to tell me the angle. Here, you cannot tell. However, there is something we know. It is the sum of angles in a triangle is equals 180 degrees. Since triangles have 3 angles, any triangle you bring, add 3 sides, you will get 180 degrees. Which means, add the 3 angles rather, which means if you add angle C, B and A plus B plus C, the total angle will give you 180 degrees. Which also means, if I say here is 60 degrees, and I say here is 30 degrees, and I say find this angle, with this, I've given you the information you need to find this angle. We know that A plus this plus 60 plus 30, everything will give us 180 degrees. This means A plus 60 degrees plus 30 degrees is 90 degrees. A plus 90 degrees is equals 180 degrees. Collecting like terms, A is simply 180 degrees minus 90 degrees. So that should give you 90 degrees. So theoretically, that is the value of A here. But A here can't be 90 degrees because this is not 90 degrees. But I'm just solving based on the values given for you to know how to find A. In geometry, 90 degrees is anything like this. Any angle that is inclined, that is forming a right angle, this is 90 degrees. Therefore, we can refer to here as 90 degrees, which is also referred to as a right angle. How about I give you something like this? A, B, C, side A, B, and I draw something like this. And I put another angle here. And I say this angle is S, find S. What would you do? Instead of thinking too much, there is a formula you can use. What is the formula? The formula simply states that if you have an exterior angle, angle B, A, and C are inside their interior angles. Now you have an exterior angle. The exterior angle of a triangle or of this triangle is equal to the sum of the opposite interior angles. The sum of the two opposite interior angles. Grammar, right? This is it. You have a triangle like this, then you have another angle here S. So the value of this S in degrees is simply, these are the opposite angles. B and A, they are opposite A's. So angle A degrees plus B degrees is equal C S degrees. So if I give you something like this, and here I say 60 degrees, then here I say 60 degrees, and I say find S without giving you C, what would you do? You simply say that S degrees is equal to 60 degrees plus 60 degrees, opposite angles, and that will give you 120 degrees. This is method 1. There's another method you can use. If I give you something like this, there is C here, and I say find S, we know that the sum of angles in a straight line is 180 degrees. If you don't know, no. If I give you something like this, straight line, this angle is 180 degrees. If I cut the straight line into two, one side becomes 90 degrees, the other side becomes 90 degrees. So this forms a right angle, this forms another right angle. 90, 90. So everything 180 degrees. We also know that the sum of angles in a triangle is 180 degrees, which means 60 degrees plus 60 degrees plus C, everything will give us 180 degrees. And we have 60 degrees and 60 degrees. That is 120 degrees. What is left? We need another 60 degrees to form 180 degrees. That means here is also 60 degrees. If here is 60 degrees, look at this angle. This angle and this angle, everything will form angle in a straight line. And what is angle in a straight line? It is simply 180 degrees. Now that we already have one part of the straight line to be 60 degrees, the other part will be 180 degrees minus 60 degrees. That is 120 degrees. So anyhow you solve it, you get that. But this formula is also helpful. Exterior angle of a triangle is equals the sum of the opposite interior angles. So the next thing you should know about triangles is that some triangles can have the same sides, some can have different sides, and so on. If you have a triangle like this, let's proceed with our convention. Let here be capital B, capital C, A. If you have something, if you are given something like this, 1 here, 2 here, 3. This sign simply means that the three sides are different. So if the three sides of a triangle are different, it also means that the three angles are different. We have triangles like this. So any triangle you see that the three sides are different and the three angles are different, they are referred to as scalene triangles. It means if here is 5 meters, here cannot be 5 meters, and here cannot be 5 meters. If here is 5 meters and here is 6 meters, here cannot be either 5 or 6 meters. Then if this angle is 60 degrees, this one cannot be 60 degrees, and this one cannot be 60 degrees. Everything must be equal. These are scalene triangles. Now you have some triangles where you see something like this. In this type of triangle, similar markings means equal. It means this side and this side are equal. It simply means two sides equal. And what happens when two sides are equal? When two sides are equal, two angles are also equal. So if this side and this side are equal, it also means this angle and this angle are equal. Then this angle is different and this side is different. So a triangle where two of the sides and two of the angles are the same, they are referred to as isosceles triangle. Now, when you see a triangle and you see something like this, like this, like this, like this, which means the markings are the same. It can be 3 markings the same or one marking, any of the markings. So long you have similar markings throughout, it simply means that the three sides and the three angles are equal. It means if here is 2 meters, here is 2 meters, and here is 2 meters. And if the sides are equal, the angles will also be equal. So if we have three angles in a triangle, and the three angles are equal, and the sum of angles in a triangle is 180 degrees, it simply means here is 60 degrees, here is 60 degrees, and here is 60 degrees. This type of triangle is referred to as equilateral triangle. So if here is 3 meters, here is 3 meters, and here is 3 meters. So when you have here is 90 degrees, here is 30 degrees, here is 30 degrees. So from only this other part, you'll be able to form special angles. Now when you have a triangle like this, one side is written like this, straight line, it's not bent. It means here is 90 degrees. So any triangle in which one of the angles is 90 degrees is referred to as right angled triangle. What am I doing? Right angled triangle. Now look at something. In plane geometry, we have different types of angles. We have different types of angles. But before then, look at something. You see this one, something like this. The sum of angles in the circle is 360 degrees. So for something like this, here is right angle, 90 degrees. Here's another right angle, 90 degrees. Here's another right angle, 90 degrees. And here is another angle, 90 degrees. So everything is 360 degrees. So making use of this side, when you see an angle coming like this, and you call it theta, what should be the first thing to come to your mind? It simply means that if everything here is 90 and this angle is formed here, this angle is less than 90 degrees. So we don't know the angle, but one thing we are sure of is that it is lesser than 90 degrees. So this type of angle is referred to as acute angle. ACUTE. Now, something like this, you see an angle like this. So like here, like this. We know that here is, from here to here is 90. From here to here is another 90. But this angle is stopping here, which means it is more than 90 degrees, but it is not up to 180 degrees, since everything here is 180 degrees, and this guy is stopping here. So this angle here is referred to as obtuse angle. It simply means that it is greater than 90 degrees, but it is lesser than 180 degrees. Now you have an angle like this. So this angle is 90 degrees. It is referred to as right angle. This is why any triangle with one side to be 90 degrees is referred to as right angled triangle. Then you have something like this, and you see an angle like this going like this, theta. You know that this here to here is 90, here is 90. Then from here to here is another 90, but this one is cutting here, which means here is acute, less than 90. From here to here is 90, but this one is not up to here, which means here is another acute angle. Therefore, when you add everything here, since here is 180 and we have addition and addition, everything here is greater than 180 degrees, obviously, as you can see. However, it is not a complete circle, which means it is lesser than 360 degrees. So any angle greater than 180 degrees but lesser than 360 degrees is referred to as reflex angle. So next, let's look at terms used in plane geometry. Ladies and gentlemen, as we go far in plane geometry or after plane geometry, when we are solving questions, there are terms you will keep hearing. It is good for you to familiarize yourself, to acclimatize yourself to these terms. The first one is alternate angles are equal. If you are given two parallel lines, do you see a line crossing here like this? If this happens, you see one angle going this way and another angle going this way. So it's just like this. Exactly. So two parallel lines, but one going here, one going here like this. So this angle here and the same angle at the back, they are referred to as alternate angle. Here and here. So they are alternating. So alternate angles are equal. Then A and B, as you can see, they are alternate angle. This one is here, this one is here. So example again, here and here, right? Now, what this one is forming in the forward direction is the same thing that this one is forming in the backward direction. So this one is coming this way, this one is going this way. So they are alternate to each other. And anytime you see alternating angles, they are equal. So in this case, this angle C is equals angle D. If angle C is 30 degrees and I say find D, D will also be 30 degrees. Angle A is the same thing as angle B. They are referred to as alternate angles. Now, corresponding angles are equal. When you have two parallel lines and you are given an angle like this, an angle like this, look at something. This angle here, if I give you this angle here and I say find exactly this angle in the other line, you simply tell me that it is like this. If I give you another line, this angle here is also something like this, is also something like this. So when you have parallel lines, the angles that are occupying the same position, they are equal. So this one is occupying the top position here, top position here. C and A and B, they are corresponding angles and they are equal. If A is 30 degrees, B must be 30 degrees. Now look at the bottom, here and here. They are occupying the same position. Parallel line, bottom, line crossing. So the same position C and D, they are corresponding angles and they are equal. Now here, sum of angles on a straight line. So the sum of angles on the straight line is 180 degrees. If you are given a straight line like this and you are given angles, they are sum. Adding A and B, you get 180 degrees. Or if I give you something like this, so you have this angle, this, everything is being formed on a straight line. The sum is equals 180 degrees. Then interior opposite angles sum to 180 degrees. Look at it. You have a line, angles are formed. This and this, they are interior opposite angles. If they are to be on a straight line, they will also be 180 degrees. But look at what is happening. Instead of this one now to come out here, it says no, I'm not coming out. I have to be inside. So on two parallel lines, two angles are formed inside. They are forming big boys. However, when you add the two angles, you form 180 degrees. Don't worry, just understand now. You see the applications later on. Questions shall be solved. Then vertically opposite angles are equal. You have a cross like this. Cross like this. You tell me A and B, they are opposite. They are vertically opposite. They are facing each other. D and C, they are vertically opposite. They are facing each other. So vertically opposite angles are equal. If B were to be 30 degrees, A will be 30 degrees as well. What is the application of all this? You draw something like this, they will tell you, they will put 30 degrees here. Now they will say find D. Instead of solving and wasting your time, just look. They are vertically opposite angle. So D is equals C is equals 30 degrees. And finally, sum of angles at a point, they will give you 360 degrees. If you have a point like this, you see different angles, they are coming at a point, forming something like circle. If you add everything up, you get 360 degrees. What is the application of this? If they give you these angles, the angle 30 degrees, 20 degrees, 10 degrees, 5 degrees, and only one is missing, you know that if you sum every other angle up and subtract from 360 degrees, you get the one that is missing. That is vertically, that is sum of angles at a point. And don't forget, the sum of angles in a circle is 180 degrees. Sum of angles in a straight line is 180. Sum of angles in a circle is 360 degrees. Sum of angles in a triangle is 180 degrees. Angle in a straight line, 180 degrees. Angles at a point, 360 degrees. Then a right angle is 90 degrees. Ladies and gentlemen, plane geometry, triangles and angles. That is it. I hope you found this class helpful. Feel free to tell me how you feel, and don't fail to tell others about Flash Learner's YouTube channel. I urge you to subscribe to get notification of my new videos, because we will have more than 10 videos on that geometry alone. Thank you. I am Isaac.